Before we get started, if you haven't subscribed to the channel, please consider subscribing. In this video, we'll take a look at how to estimate logit models in R, as well as how to get estimation of average marginal effects in R. And for this, we will be using the affairs dataset available from the AER package. So let's take a look at the problem that we'll be solving first, and then we can get into the R script. Okay, so first thing is we'll be using the dataset affairs from the library AER, and we need to construct the following variables. We need to get a variable called regular, which will be a dummy variable for regular or frequent affairs, female for a dummy variable for females, and a dummy variable for religious people. Apologies for the mistake of spelling here. Okay, first part, we would like to estimate a maximum likelihood for a logit model for the probability of having regular affairs. And we'll be using the following explanatory variables: education as a continuous variable, years married, age, children, female, and religious. We can use the GLM function in R to estimate this, and for logit, we would have to use this option, family equals to binomial, and then specify that we want to use the logit. So let's look at part A in R. Okay, so first we set up the options so that we can display 4 digits maximum, and then we start the library AER. We also use the library margins, and then we load the dataset affairs that's available in the library AER. All right, then we define the dummy variables as mentioned in the problem that we are solving. Regular equals to 1 if affair equals to 12, weekly, monthly, or daily, and then female equals to 1 if gender is female and otherwise 0, and religious equals to 1 if religious and otherwise 0. You can look at the dataset once you load it, and you can see what are the different variables and what are the different labels in those variables. I won't go into that part right now. Okay, so affairs, regular as numeric when the value of affairs is greater than 11, that's 12, and then females and the religious. Okay, so we do the dummy variables, and this is the part that's important here, which is the estimation of maximum likelihood for the logit. So we use the command GLM. We define it in a regular way, the model that we do. So the dependent variable here is regular. The independent variables are education, years married, age, children, female, and religious. We specify the options that family equals to binomial, link is equals to logit, and then we specify the dataset to be the data affairs that we just loaded at the very beginning. And then let's take a look at the summary of the model. And this is basically our logit model. And we can see what we have here are basically the logit coefficients. I'll get into the interpretation quickly, but let's take a look at the other parts in the questions. So the part B is telling us to test the following hypothesis at 5% level. Men and women are equally likely to have regular affairs. Religious and non-religious people are equally likely to have regular affairs. People with children are as likely to have regular affairs as people without children. So again, we are basically taking a few hypotheses, and we'll be using the estimations of this model to test those hypotheses. So we don't need to run individual tests here because these are all individual hypotheses for each specific particular variable, so we can just look at the p-values for these variables to interpret. So looking at the p-values, the estimate of female is not statistically significant, right? Okay, that means it is not statistically different from 0, this estimate. Hence, there is no statistical difference between male and females having regular affairs at the 5% level. In other words, both are equally likely to have regular affairs. Okay, we are done with our first hypothesis test. The second one, the coefficient estimate for religious dummy is statistically significant at the 5% level. So this is the estimate of the religious dummy, and it has 2 stars. So yes, it is definitely statistically significant at 5%. This means that there is statistically significant difference between religious and non-religious people, and we can see that the estimate is negative. That means religious people are less likely to engage in an affair compared to non-religious people. And then the third hypothesis here is that the estimate for children, yes, is not statistically significant at 5%, which is this one. So this is statistically not different from 0, and hence people with children are as likely to have regular affairs as people without children. That's what this model and this dataset is telling us. And then the last part here is in this model, this is basically, again, we are getting into the theoretical part of logit models. The marginal effects of regressor x on the probability of y equals to 1 is defined as the derivative of the probability that y equals to 1, conditional on x, with respect to x. And we are defining the derivative as the function represented by the small letter f. Okay, where basically this f is the derivative of the cumulative CDF represented by the capital letter F. And then the average marginal effect is basically the average across all observations or all individuals in this sample. And we can estimate this as 1 by n, so basically sample mean. Okay, so in the logit model in part A, estimate the average marginal effects for education and years married. Are they significant? What are the directions of the effects? So now we get into estimating the probabilities using the logit model. We can use the summary command, and here we'll be using the margins command. And we are using the margins command on the model logit, the model that we estimated, and the variables that we're interested in are education and years married. And here are our results, and we have the average marginal effects right here. So both p-values are less than 5% if we look at the p-values. So we can consider them as statistically significant. All right, that's great. They're not statistically same as 0, they're different. The average marginal effect for education is negative, while that of years married is positive, right? So it's telling us that the more education an individual has, the more likely he is to not engage in affairs. Whereas the more the years of merit increases, the more likely that individual becomes to engage in affairs on average. And this is the effect of these variables on the probability of engaging in affairs. This is not that specific particular probability itself. All right, so this is how we can estimate a logic model in R and also get their marginal effects. If you like my videos and find them helpful, then please support my work by subscribing to the channel.